we will discuss how to start using FiftyOne in our computer vision projects, and we will have too much fun. I will try to do that in these 90 minutes. It's a long session, but I will create, some introduction about the topic. I also want to learn more about you. So let's just have that in mind. I will make some questions and we will make the interaction through the chat. So just some housekeeping items. So we have the Q&A section or the widget. If you can ask any questions, if you have any questions, you can ask those at any time. So related with this workshop for sure. So we will use the chat to interact with you all. So you can also interact with others. But remember that the chat is private. So for that reason, after the workshop, we cannot see this chat anymore. So if you find any interesting link during the webinar, during the Getting Started workshop, or you want to keep a conversation with us at the Voxel 51 DevRel team, please join us in our Discord channel. So let me start the presentation. So with some questions, I really want to know where you are connecting from. So let me read you in the chat. So I'm in Raleigh, North Carolina, in United States. And now is my 12 p.m. So where are you located? Let me just read you. Ohio, Adonai, Ohio, United States. UK, Bay Area. Anything from Spain? Spain, great. Boston area. Switzerland, India, Toulouse, France, Germany, thank you. So it's great to see you all here. Canada, that's amazing. So thank you and congrats, because it's also great to see you, all of you here, no matter what time zone you are. So we are all together. Okay, let's continue. So we have, if you have been working in computer vision field, so maybe this message will resonate with you. So you have been facing maybe bugs in production, maybe, yes, I have faced those. And normally we focus on the improvement of our models, even if we don't understand our data or our data is a chaotic mess. What if I told you that this is not always about collecting more data? That we can check models mistakes and redefine critical edge cases that are important for our production system. So let me jump into a demonstration. I really want to show you. We will talk about FiftyOne, but maybe some of you are not familiar with FiftyOne, maybe yes. So I will be sure that after this webinar, you will be familiar with FiftyOne. So let me jump in this demo. So imagine that we, all of us, we have a consultant company and we have a lot of customers for quality control process. So we have the semiconductor industry, maybe we have the textile industry as well. We have maybe another kind of, personal items. Also, maybe we have the food industry as well. So what if I told you that, that we realize that the textile customer has some issues and with a model, because a lot of customers return carpet rolls with quality issue. So that means that our model was not able to catch those issues. So we have this carpet information and we were not able to catch those with the model. So we revisit them and realize that there is a damaged machine that was leaking oil and leaving small metal parts over the carpet. So we have multiple issues there. So we improve the data set on those critical edge cases and retrain the model. So when we have this, we were able to validate that the new model is even better than the previous one with the new information or the new damage that we can see in the data. So in this demonstration, I showed you FiftyOne application. So what FiftyOne is, we will answer that question during the webinar. But basically, as you can see here, we can navigate different kind of data sets, different unstructured information. We can validate annotations. We can also evaluate models. But also we can see the raw data. So FiftyOne helps us to navigate data no matter the stage that we have in our process. So let me come back to this. Okay, I almost forgot to introduce myself. So my name is Paula Ramos. I have a PhD in computer vision and in machine learning. I think I'm a senior computer vision machine learning advocate lead at Voxel 51. And I have been working with AI before AI was cool. 20 years ago, we just have slow CPUs. We didn't have transformers or expensive GPUs, but at the end, with a lot of enthusiasm about the work that we are doing or we have been doing, we get things done. So, and this is the important thing. So the AI world has been changing too much during these years. And for sure, now we have a lot of AI tools that could help us to improve our performance of our products and models. So if you want to keep a conversation with me, follow me on LinkedIn so you can scan the first QR code. If you want to download this presentation, scan this QR code, and also join our community in Discord. So all the resources that we will show you today, you will have access that, so you can download the presentation, scan this QR code. You will have access to all the hands-on experience, but also you will receive an email after this getting started workshop today. And also you can watch a recording in YouTube, in Voxel 51 channel in YouTube after this. Okay, so before this webinar, are you familiar with FiftyOne or no? Is a question that I want to see in the chat. If you are familiar, just drop FiftyOne. If you are not familiar, drop 50, and I will read that through like a little survey here, live survey. 50, 50, 51, 51, 50. Okay, 51, say something, 51. That's great, Adonai. Okay, it seems that we have a mix of people that maybe they are familiar, maybe not, and no worries. So, and I think that we are here to know what FiftyOne can mean to us if we are working in the manufacturing industry. It's something that if you are not familiar with FiftyOne, no worries at all, because I will show you some basic and fundamentals of FiftyOne. So, and here we go, the goals for today. We have 3 simple goals. The first goal is understand how FiftyOne makes your computer vision project better. The second object or goal is you should get the hands-on experience on FiftyOne, the open source project. And the final goal that we have is I want to provide you a solid foundation to go for and explore. We finished this webinar, and I invite you to explore your data sets, your models with FiftyOne. And let me know how that exercise was. So before to start, I want also to keep the language in the same location as you and I. We are thinking about the same. So let's make some definitions first. So what visual AI means. So we have been talking a lot about AI. We have been talking about multimodality, 3D point clouds, video, images. So visual AI means that this is an AI branch that can help us to interpret, analyze, and make decisions on visual data. So, and visual data means videos, images, 3D point clouds, and multimodal data. So in the past 3-4 years, we have been part of the AI text revolution. And now it's time for the visual AI revolution. And that is a normal process. The human beings, all at the very beginning, they started also with language, with text, and they moved to visual later on the story. So this is a normal trend that we have. So what now with this visual AI revolution, we can start making integration with unstructured data and new AI models. But there are a lot of things to add to this next revolution in AI. So that you can see there, real-time inference, self-learning AI. And for sure, something that is really important for us today during this workshop is data-centric AI approach. So this revolution comes with a change in our paradigms. So we have been suffering a lot of pains with our projects. So 80% of AI projects fail in production. So we can see bias issues, lethal physical danger, and reductions of model performance. So, and the common thing here is that we have been paying too much attention to retrain our models with more data. And so we are thinking that solves the problem. And that is the model-centric AI approach that brings real-world consequences. So we will see, how the real reason that we have these problems in production is that we don't know our data. So this is a question mark. Do we know our data? So maybe the answer is not. We don't know our data. We don't know the critical edge cases that we need to include in our models. Or basically the actual teams are struggling to match with model errors due to bad data or spending too much time groveling data. So what is the answer here? What is the solution? So the solution is build better data sets. And how we can make that? We need to choose our path, and we have two options. We have the model-centric approach that I already illustrate that, or the data-centric approach. So for me, this is clear because I would like to reduce bias and errors. I want to be focused on data set quality. And I also want to create like a cost-efficient optimization process. Instead to have bias issues, complex models, and high computational costs of my systems. So, and if this is not clear for you, I want to show you, this illustration. What is your path? What will be your choice? Do you prefer to go to Disneyland, or do you want to go to the Lord of the Rings land? So it's up to you. But my selection is I will switch to the data-centric AI approach. So AI success is not just about better models, it's about better data sets. And that is the specific point where FiftyOne helps. Now, you understand why visual AI is the future. So now let's see how FiftyOne helps us to build better data sets and improve the model performance. So what FiftyOne is. So it's really important. So the definition that we have is FiftyOne is the only open source data-centric AI solution. It helps us to curate, visualize, and analyze data sets. We can also streamline annotation workflows. We can find and fix labeling mistakes. We can identify and correct model failures. And for sure, FiftyOne makes visual AI a reality. That sounds too much marketing, but it's real. So FiftyOne makes visual AI a reality. Okay, let's move forward. What kind of computer vision task we are supporting with FiftyOne? So good news, we are supporting all the popular vision tasks. That means that we are supporting classification, detection, segmentation, instance segmentation, semantic segmentation, polygons, polylines. You can read that, key points, geolocation, multimodal embeddings, multi-view data sets, and all these covering different kind of visual format such as images, video, 3D data, and multimodal data sets as well. So, and the role of FiftyOne in the data-centric approach, so FiftyOne helps us to load data, filter data, visualize embeddings that are super important, make model comparison, integrate data management and model evaluation with the complete MLOps pipeline. So if you think about the pipeline, how FiftyOne fit in the complete MLOps pipeline, I will say that FiftyOne bridge the gap or create better data sets and help to improve the model performance. But with FiftyOne, we can curate the data set, evaluate the model, annotate also some images or information. But with the orchestration and integration system that we have multiple solutions around the computer vision workflow. So FiftyOne can easily integrate with data annotation tools, model training tools. You can fine-tune your model. Also have the capability to always monitor your model, retrain with better data sets, and improve the model performance in production. This is super important. So I think that it's time to start with the hands-on experience. So drop your questions at any time in the Q&A widget. So Adonai will help me with that, and we can also keep some questions at the end, so we can answer those questions live. So what is the expectation that I have from you in this workshop? So pay attention to me, pay attention to what I'm talking about. I will show you, and I will jump in between the SDK that we have and also the application. You will have access to the code, so you can repeat this on your side. And we have an excellent documentation, and you can revisit that documentation and revisit this repository. So what we are doing, or what we want to do today, we will cover fundamentals of FiftyOne. We will cover, for example, query and filtering. We will explore embeddings. We will talk about advanced data curation and integrations. We will see how we can evaluate models with FiftyOne. And we will talk about complex data sets or new data sets. So this getting started workshop is about manufacturing, visual AI in manufacturing. So the main data set that we will use for this workshop is the MBTech AD. But at the very end of the webinar and the workshop, we will talk about some complex data sets, new data sets as MBTech AD, but we will talk about worker safety data sets and also video analytics. So that for sure you will have access to those resources and you can try this by yourself. Okay, so let's start. Let's start with the notebook number 1. So let me close these tabs. And let's start with the notebook number 1. So as a little reminder, let's just give me 1 second. I will open this is the repository where you can find all the information. So I think that Adonai already pasted this link in the chat. And so we are estimating that if you want to navigate the whole guideline, it will take maybe 2 hours, 2 hours and a half. So for this workshop, we will talk about mainly the first 7 notebooks, and as a homework, you need to run the other 4 notebooks on your side. So this is a really way to document the workshop. Just access this and navigate this by your own. The link to the repository. So this is the repository. So basically, you can access here all the notebooks, and you can see this. You can view this in the GitHub as well. So basically, you will have access to the repository. So maybe makes sense to copy and paste this to all of you. Okay, so we will start with the first notebook to create some foundation information about FiftyOne. So as simple as pip install 51 is all that you need to do. So we have multiple ways to explore and connect with datasets. So you can, if you have the datasets locally, you can access the directory and just call that data into 51 format. You can also use Hugging Face Hub datasets and export and import that dataset to your notebook as well. So you can also download from Google Drive and just work with that. So if you have a Google storage and you want to connect your buckets with 51, you need to use the 51 Enterprise. But all the workshop today will be around the open source solution. So something that is really important is just as simple as pip install 51, and you need to import 51 as a FO in this case. And we can load the dataset. In this case, we will load the dataset using Hugging Face. The Hugging Face integration that we have from dozens of integrations that we already have with other libraries. So as simple as create the dataset name and just load the dataset from the Hugging Face hub. Is super easy. So you can also take a look of an alternative way to download dataset and just try to bring this from the directory if you have this in the local environment. So let me show you what this notebook is about. So I'm using the MBTech dataset. So basically this is the MBTech AD. So let's jump on this. So we will use this data set. So for this getting started workshop mainly. So what we have here, we have ways to, what you can see here is the GUI, where we can explore the data set. We can have here, we could see here all the metadata. So for example, I can select the labels that I want to take. I want to see, I have bottles, I have cables, capsules, carpet, grid. So I can select here the label, for example, and I can see all the information that is categorized as a bottle. I can also take a look of the defect and say, hey, I want to see, we have for this specific data set, we have a specific definition of the defect. It's not bad and good. But we can see maybe broken large. So we can see broken large. And this is coming directly from the directory from MBTech. Okay, so we have multiple ways to manage datasets. Let me just come back to my presentation and I will explain you that. So a little recap, as simple as pip install 51. And in this case, we are using Hugging Face Hub. And we have already this MBTech AD dataset in the Voxel 51 hub in Hugging Face. And we want to make this persistent. What that means that we are saving basically the database in the system. And persistent means if I just turn off the notebook, when I come back to the notebook, I can load that from the storage that 51 has, but it's not that we are recreating a new storage, that we are just saving new files. It's just pointing where the data is. And we can just bring that again. You can also overwrite or not. Those persistent and overwrite are by default are false. So if you want to keep your data set, your database in your notebook, you need to make this persistent. So we have two different ways to work with 51 through the SDK, where basically I showed you the code. We have functions that we can navigate the data set, we can load the data set, or you can also visualize that in the app. So to open the app, you need to launch the session. So this is super important. You need to say session equals 51.launch app, and you need to call the data set. So let's talk about the 51 architecture. So imagine that we have like a client server structure where basically we have a back end and a front end. So we have for the back end, we have the data set storage, we have the indexing and queries. And for the front end, we have all the visualization environment, the user interaction, and classification labels, and so on. regarding datasets, types, and formats. So we support different kind of formats. I mentioned this before: images, videos, 3D point clouds, and multimodal information. But also we are supporting a lot of metadata. We don't have limitation on the metadata. You can include whatever metadata that you consider in your project. So maybe you have timestamp, maybe you have patterns, maybe you have some information coming from other sensors that also you can add this here. But I want to mention that how this is working. So basically the 51's data management structure, you could have sample metadata that basically could be related with file paths, dimensions, properties. You can also have embeddings and features from your data, like similarity search or feature vectors. And this is just an example. It's not that we have just these options. So we have multiple options, and this is just an example. You can also access through the data management structure annotations and labels, for example, bounding boxes, segmentation masks, classification labels, and also model predictions, like what is the output of your model. You can include that there, and also evaluation metrics. So this show us where 51 fits in our production system. So basically we have raw data. We can manage raw data. We can manage annotations, label data. We can also manage all the data that is coming from with predictions with our models. And with that, we can see a lot of integrations with different models and see and gain insights from our data sets. So, and the dataset structure hierarchy is simple. Imagine that we have a database, and the database is basically a collection of visual data, and the sample is the individual image or video or 3D point clouds, and that basically is the row of our table or database, and we have fields. Every single field is a column where we have a specific information about that specific sample. As simple as that. So let me jump in the notebook that I have here. So we can explore the data set, and when I'm running this locally, but also you can run this on Colab. You can run the installation, and I'm running this locally. So basically what I have here, so I'm printing the data set, and I can see some information about my data set. Say this is the MBTech ID, the media type is images, I have the number of samples, persistent is false. By default, I make this false, but I need to make this true. And I have all the sample fields here. So I have, important category, defects, split, defect mask, and I'm also printing the first sample, so I can take a look of my first sample that is here. So I have an identifier for my sample, where my sample is, and all the information. If I have if it's for example, this is a transistor, I have category, that label where the name of the class is, and I also have maybe information about the defect. It's a classification, and I can see if it's a label good or a specific defect for this data set. So let me come back to slides. So where we can see here, so I can also print last, first. I can also print data set by a specific ID and take a look of that. So in this one, for example, I can see the category label, the defect label, and the defect mask, like a mask path. So, and you can access this information and run whatever you need. So, okay, so we have also data sets, curing and filtering. This is another step. We will use the same notebook. What I want to show you here is for querying and filtering is that we need to use some fields. So we can use some fields and say, hey, I want to use expressions, and I want to define in my data set which samples have the defect label as a scratch. And I want to create a view of that. So the first thing that we have, so we can create like a subsets from our data set, that is the biggest one, with one specific filtering or rule. In this case, I say, hey, I want to take all the defect labels that has a defect called scratch and run this. So when I run this, I'm also launching again the session. I can also refresh the session. So we're basically, let me see. Here, I can see all the defects with the scratch. So, and this is not just wood, also we can see capsules, and also we can see metal nuts, for all peels, all the categories that we have here. So what if I jump and say, hey, I want to see in that specific view, what is the category wood, and I can filter this. So I can run this and take a look of this. And I can see this is just wood. I can see 21 samples for this specific view, where you can see here we have two rules. One, curing the data set, and the second one, filtering the data set. So you can see the scratches there. So this is just a recap of what the code that I showed you. You can see this better. We have curing the data with the first match, and we are filtering the data with the second match. So, and that is the way that we are manipulating data in FiftyOne. So basically, curing is used to retrieve specific samples that match a condition for the entire data set. And the filtering is over one specific subset. And we can see that we have the way to manage data in FiftyOne is you have the data set as the original data set with all data. The view is a temporarily filtering is a filtering data set subset. And finally, this is temporary because that is not living anywhere. It's just a subset that FiftyOne is creating. That means that when you shoot out the notebook, that will disappear. So if you want to create a copy of that view, you need to clone that view. And that clone is like an independent data set copy or subset copy. So how that is working in the code. So you need to create a new data set. For example, you can create the view. Remember that we have the view is the filtering information that we have, and you can just clone this as a new data set. You are cloning this, now you are able to export this data set. Why this step is super important? Because normally when you need to find these critical edge cases for retraining your model, you need to export that data, and you need to have this way to manipulate the data. So let me show you another thing that is also really important in FiftyOne. I will just clean this out a little bit, and I will make this a little bit smaller. And we have panels. Here, if you can see my pointer, this plus sign, so I can click here, and I will select dashboard. So this is a plugin that we have, and so basically this is something that is really cool from FiftyOne, that we could add interactive plots in this place, and we can inspect our data sets. So let me run this an example. Let's see that we want to see the categories that we have for this specific data set. It's a categorical histogram. I will select the field, the category field that I want to put in this graph. I want to see category label. And I want to make this for the whole data set. I don't want to update this on view change. I will create this plot. So here you can see the bars, but this is totally interactively. So I can interactively play with my data set. Say I want to see bottles, and I click the bar with bottles. And I also want to create maybe another plot with add item, another categorical histogram with defects, for example. And I will select defect labels, and I will make this, in this way. So what we have here is, okay, I have cable. Okay, let me edit this one. So I need to update this with the view. You update the plot. Let me just, I will close these filters. So let's go to wood. That is the example that we are working with. And we have, in wood, we have this kind of defects: color, combine, wood, whole, liquid, and scratch. So we have color with 8, we have combined with 11, we have wood with 266, and we have whole with 10, and liquid with 10, and scratch with 21. So you can explore all your data set here, So, and something that I really want to know from you, if I can see the chat here. Let's see if I can see the chat. Yes. No, why? Okay. Yes, I can see the chat. So a question for you, and I think that you will win a swag here if you are paying attention to me. If you let me know what is the defect with less counts in the wood category. So please drop that in the chat, and the first answer. Great job, Jim. Yes, that's color. Is so, and after this, so please connect with me, and I need your email, and I will send you a swag box to you. Thank you for paying attention. That's amazing. Okay, let's move forward now. I don't know if we have maybe some questions. So Nai, do we have any questions? No open questions?
Yes, Paul, we have one. I already answered it, but if you want to complement, the question is, what is the minimum number of data sets required so that AI can easily differentiate between all photos? Is there like a minimum number of data set size? That was the
So
question.
that is a difficult question. I think that we don't have a magical formula to answer that. Depend for sure of the project that you are running. So for manufacturing, for anomaly detection in this case, so it's simple. I will say it's simple, but at the end it's not simple because, for example, you have the same scenario, so you are not changing the background, so you have the same object, so you try to keep the same object every time on the same spot. So the number of data in that case is depend of the conditions that are varying in your project. So maybe you have lighting conditions that are varied. So maybe you have the position of the object is not always the same, or the background is changing. So depending of how many variables you have that is changing your image, you need to increase the data in the data set for just capture that variability. So it's not a magical formula, but yes, I think that with FiftyOne also you can explore a lot of, we have a lot of indexes that you can gain insights from your data set, and this is something that we will talk now. So, but just a little example. So for example, I have a robot behind me, and I'm using the color cubes, it's a toy demo that I normally I'm doing for anomaly detection. So I create a model that was working really well just with 40 images. But if I move the robot to another location, I need to create the data set again because my lighting conditions are changing. So depend. But yes, if you want to have a robust model, So you need to include all the variability. Thank you, Adonai. Okay, so let's continue. Something that we are mentioning here are, gain insights from our data set. So remember that I told you at the very beginning, we don't know our data and how we can understand better our data set. Let's jump to the notebook number 2, where I will show you. Let me close the notebook number 1, and I will show you the notebook number 2, where we will explore embeddings. I showed you this at the very beginning with demonstration. What embeddings means is we have a panel where we can see dots for every single image that we have in our dataset. That for sure by default is uncolored. So we can see all these points with no colors. What we are adding with FiftyOne, you can color this by the category label and see that we are clustering. So embeddings are helping us to understand why the data set is moving in some clusters. So in this case, we have clusters by category. So what happened if I put here, for example, defect as the way that I want to color this? That will be a chaotic mess, because maybe we have in the same, let's see, maybe this one that is carpet. So we have in the same cluster, we have, and it's difficult to differentiate where those defects are, and so for sure that the insights that we can win to the data depend of what we are looking for. So in this case, the embeddings that we are using that are coming from Clip are working pretty well to create clusters per category. So we could see here 15 categories from MBTech ID, and we can see that those are colored by the specific category bottles. We have here grid, Okay, so how this is working? How is possible to run that? So and remember the dashboard, right? So I can run also this like an interactive panel. So I can interact with my data set and I can understand what I have here, for example. Okay, I have here the metal knot, good and bad. And what is going on with this outliner? I can select this and, okay, this is flipped. This is a flipped metal knot. So these ones are not flipped, are normal, and these ones are flipped. And this is a defect because I need to have in one specific orientation my metal knot in my conveyor belt. So this is the kind of insights that we can win with FiftyOne, that we can, it's something that maybe that is difficult for us to detect just inspecting manually the data set. Okay, let me show you how this is working in the notebook. Okay, let me close. Okay, I don't want to close this. Let me jump to the this one. So this is the notebook number 2, where basically we are loading the data, same step that before. What we are doing here, we are loading the clip model. We are using embeddings are coming because we have a model that could expose the feature vectors of my of the model. So in the feature vector is some features that we have per image. So if we have an image, for example, 1024 by 1024, we could have embeddings even longer than that. So we could have embeddings is one single vector, but we have n dimensions. These n dimensions could be maybe 2000, more than 2000, 4000, and that is impossible to visualize. What we need to do, we can calculate those embeddings using the clip model, for example, in this case. We can also use ResNet 50. We can use multiple models, Blip. We can use multiple VLMs that we have right now in our model zoo. Also, we can use your own model to calculate the embeddings. but how we can visualize those embeddings as dots in a 2D plot. So because we are running, so we have here, we are using this model, we are calculating the embeddings, but when we compute the visualization, behind scenes, you don't need to be an expert on that. So behind scenes, we are making a dimensionality reduction using different methods. So for example, in this case, we are using UMAP, but you can also use TSNet, or you can use also principal component analysis. So this is how this is working. And for sure, after you run the embeddings and run the compute visualization that we have in FiftyOne, you can explore that you have a new field in the data. So that this is the embeddings vector. This is the embeddings that we have for and as I mentioned before, it's difficult to visualize what is going on with that, but when we have the dimensionality reduction, we can see that easily in a 2D plot. Let me come back to this one. And I want to grab, and maybe for the ones that are not super familiar with embeddings, maybe I will repeat a little bit here. So when we are making this transformation to embeddings, we can gain insights from our data. So we convert to embeddings the images, and we transform those images into numerical vectors, normally high dimensionality vectors. And then we need to reduce the dimensionality, but with that reduction, we are preserving the relationships in that specific embeddings. And then we are able to visualize and cluster. And we are able to also run the clustering process. That is something that we are doing. So visualizing embedded spaces for anomaly detection, this is super important because, as I showed you before, we could have one cluster per category, but we want to color this by defects. Maybe those are all together. We cannot see any differentiation. Maybe we need to visualize a specific model. We need to use specific models to visualize those embeddings between something that is abnormal in my data set and something that is normal. So I think I already showed you this. In this case, we are using the clip model to calculate the embeddings, and we are also calculating the dimensionality reduction with compute visualization, where basically we have something that is important, this brain key. The brain key is the identifier to FiftyOne, where I want to point this in the embeddings panel. So let me show you that with the notebook. So let me just close this. I will open the panel. So if you go to this panel, create here, embeddings, I can see select brain. And select brain is basically where FiftyOne is pointing every single embeddings in the compute visualization function. So as I showed you before, we can also make this interactively with the dataset, so you know the rest of the story. But yes, I can tag here the category label and see the clusters. Okay, any questions so far? Okay, it seems that we don't have questions. Anyway, let's move forward and let me explain these. You saw that in the code, here in the code, I use load to model. And I'm also importing FiftyOne.models as FOCM. So FiftyOne has a model zoo and a dataset zoo that are super important because we have a seamless model integration. So you can use pre-trained models as clip, for example. So basically we have hundreds of ready-to-use AI models. You can use your own model because you can create something that is called remote source model zoo. So basically you can integrate your models using a URL or GitHub. In FiftyOne, you need to create the file to configure your model, and you don't need to be worried about the input tensor, the output tensor to match this with your pipeline. So if you want to have more information, maybe we can, yes, so already Adonai paste that in the chat so you can take a look how remote models work. Okay, so let's move forward with clustering with embeddings. So let me see because it's no. So you can scan this QR code or go to clustering tutorial. So where basically you can take a look of some instructions to create your own clustering process. So this tutorial is amazing. I really like this tutorial. It's clean, it's simple. You can navigate that easily. So, but I'm also prepared notebook that we can work together under the same manufacturing idea for anomaly detection. So let's jump to the notebook number 3. So let me close the notebook 2 and I will jump to the notebook number 3. So what we have here again is we have, I already have the embeddings, but normally with these embeddings, so we don't have colors, we don't have categories. So if you take a look of, I already removed the category label, and the category label is null. So we don't have categories here. So I already prepared this for the demo, removing the categories from MBTech. What happens if your data set looks like this? No categories at all. How you can fix that if you need to cluster this by your own and you don't have those annotations. So, and this is why we want to jump in the notebook number 3. So in the notebook number 3, here I already remove all the categories. So basically we have no categories, we have the label, we have the field, but this is null. And what we can do is we can generate the embeddings as we made before with load2, clip model, and compute visualization. And then we need to cluster the dataset samples with a FiftyOne plugin. So, and this is something that is really important. We have an amazing plugin ecosystem. I don't know, we can maybe paste that in the chat as well. The plugin ecosystem that we have is amazing. What that means that we have multiple ways to interact with functions that can help you to gain those insights from your data sets. So in this case, we are using a clustering plugin, but how this is working if we don't have this cluster? It's also simple, it's maybe 10 lines of code that you can use different methods. So in this case, for example, this example here, we are using k-means clustering. This is I will say, the old way to do the clustering process, right? But what if I told you, if you don't need to be worried about that, you don't need to write code about that. All that you need is install the clustering plugin. That is this one that we have here. We have basically, you need to run this on your terminal, FiftyOne plugins, download, and you need to call the plugin. So we have a clustering plugin. And then for sure, there are maybe some requirements for the plugin that you need to be sure that is also installed in your environment, in your Python environment. And then we can just launch the app and see that working. So let me show you where. So if I go here to operations, so there is one button that is called browse operations. If you open browse operations, you can create clusters. You can go there and you can provide the wrong key, for example, category cluster. And you need to select the embeddings. That is super important. You can select the embeddings. You can select the method that you want to use. In the example, in the old way example that I showed you, is a k-means. So let's select k-means and the cluster field. That could be cluster category. And how many clusters do we need to put here? The number of categories we know that MBTech AD has is 15. So, and we can just run this, okay, and execute. So basically what this is doing behind scenes, you can also run this in the delegation system, and maybe use infrastructure. But you saw this is super fast. We didn't need to use any special infrastructure, and I can see the category clustering. So basically what we have here is the numbers instead of labels. We need to run we have numbers per cluster, but we have a really amazing approach with the clustering process. So this question is for you. I don't want to cover this. I don't have time to cover that in the webinar today, but how you could move this to put some labels there. Just give some ideas and drop that in the chat, and we will see if the person that make a really good approach will win a swag as well. So think about that and how you can move this from numbers to real labels. Okay, perfect. Let's move forward. I will just review the chat, or maybe other night. Maybe you can let me know when someone make the right answer. Okay. Let's move to the notebook number 4. So we're basically, I mentioned before, we have some in anomaly detection is so tricky because you have the same scene. So some pixels in the image are changing. And basically, if you run embeddings like these common with foundation models, you can just see category labels by cluster. And just what happened if I need to find embeddings to separate defects and no defects, normal from abnormal images? How we can run that? And this is the idea for notebook number 4. So let me close number 3, and I will jump in number 4. Okay, so this is beautiful. We can see a separation in between good and the rest. We can maybe see some overlaps here or just close to, it's okay. That's normal. And this is contamination. This is, we have here the names. So if we have good here for this color, we have contamination is dark green. That I don't know if that is super clear for you, but these are the points. We have also broken small and broken large. So the differentiation with these embeddings is really nice. And I'm not using clip, by the way. I'm not using clip in this case. I am using my custom model to differentiate abnormal from normal samples. So how I was able to do that? Let me jump into the code and I will show you how. So let me jump into the code and I will jump in the number 4. Okay. So what we have here is we need to extract the custom embeddings. I'm using this, so you can use your own model. I'm using this. This is my pipeline. I'm using the custom embeddings from padding. Padding is a common model to detect abnormalities. And I'm using anomaly, that is a library that basically this library contains the state of the art in all algorithms related with anomaly detection. So what we need to do here, what we are doing here, I'm using anomaly models and I'm using the padding model. And I'm importing the padding model with 2 layers, and I have the backbone of ResNet 18. Also, you can use the ResNet 15 too as another backbone, but for this one, I'm using the ResNet 18. And you can see here the structure of the model. So we have here the structure of the model. Also, we can print here is the same. So I'm just repeating this. So what I'm doing here is I'm extracting the embeddings. I'm creating the lighting-based padding. I'm loading the image, and here I'm just extracting the embedded shapes from that specific model. So I can see that the tensor to that point, to that specific embeddings is this size, where basically the dimension of the embeddings is 100. So we have 100 embeddings for an images that are 56 in X and 56 in Y. So then I need to extract those embeddings and import that into FiftyOne, integrate that with FiftyOne. And so basically what I'm doing is I'm just creating a new field that is called embeddings, and I'm just extracting the embeddings from my model using the data set that I already have with bottle. So I'm selecting bottle. Okay. So, and I'm calculating the embeddings using padding, and then I'm just extracting that information and including the embeddings in the in a field in my data set. So this is the way. You can visualize the embeddings the same way that we are doing in the past with compute visualization. But in this case, you need to call the embeddings that you already create in your data set. And so we already have these embeddings, path embeddings, and you can just utilize that and call to visualize that and run the dimensionality reduction in the 2D plot. Okay, so Adonai, do we have any success answer in the chat about how we need to add labels to our clustering process?
Oh, give me just 1 second, please. I'm checking that.
Okay, perfect. I will move forward. Perfect. So this is amazing. This is a really useful capability that you can explore if you are working with anomaly detection, that you should explore in FiftyOne. If you already have your own model, bring the model here and you can take a look of these embeddings and see, if you have maybe some abnormal pieces in the normal pieces. So remember that if you have any questions, we don't have the option to talk, so you need to just drop the question in the Q&A widget. So, okay, let me move forward. Okay, so I want to close this with the idea that we have in FiftyOne something that is called FiftyOne Brain. So with FiftyOne Brain, we can visualize embeddings. We can calculate different indexes like similarity index. We can calculate near duplicity, exact duplicity, uniqueness, representativeness. We can also have some measurements regarding the training pipeline. If you already have the training pipeline included and you have including those metrics in your data. So I want to close this. If you have any questions about embeddings, let me know. Put this in the Q&A widget. I will move forward to the next topic. So Adonai, we have any success answer?
We have 4 answers actually that I that I would like to just mention then because I think they are good. If it's okay, or just say who is the winner because what you prefer, like
So who is the winner for you?
I think
Just
Finn. Yeah, Finn do a good answer. I think I can put Finn. I'm just
okay.
gonna write his name. Yes.
Okay. Okay, perfect. So Finn, if you please send us your email, we can send you the swag. Perfect. I love the interaction with the audience, so please pay attention, baby, because maybe more questions are coming. Okay. Thank you, Adonai. Okay, let's move forward with model evaluation. Just a time check. We have 25 minutes. As I mentioned before, I'm not expecting to navigate the 12 notebooks, but I'm almost done with the MBTech AD. and we will see some interactions at the end. So model evaluation and integration, so we can evaluate and improve models with 51 because we have more insights from our data set. And also we have advanced data curation and integration. So what we can use in this section is how we can take a look of model performance with, for example, this one is the model evaluation. That in the past, that was something that we needed to run with a plugin. Now, by default, when you install 51, you can take a look of model evaluation. So it's a native plugin that is already installed in 51. So let me, I don't know. Hold on 1 second. Okay, yes. I just wanted to be sure. Okay, I already showed you this where we fit. And I want to let you know in this specific moment that we are covering data management, we are covering annotations, and we are covering model evaluation. So question mark is what happened with the rest of the actions in the MLOps. So we have integrations that we can cover the rest of the things. So we can cover fine tuning, we can cover training, we can cover augmentations, we can cover a lot of stuff and steps that you maybe are running with your own code. So, and you don't need to make like a hard code of that if you already have this integration. So we have the flexibility with 51 to cover those integrations as well. So here I want also to make a differentiation. I already mentioned the enterprise version of 51 for the ones that already have the data set in cloud storage, like a buckets and so on. So we have two versions, the open source project, that is the one that I'm navigating today, where basically is focus on a single user. So if you are making experimentation, individual experimentation, and you have the data locally, you can use the open source project. But if you are looking to have a multi-collaboration with your team, but you have billions of samples and you are using cloud storage, and you need to have like a stream connection with the MLOps orchestration, you should use the enterprise. So here are some QR codes and links that you can follow if you are interested in one or other. So I invite you to try in browser. Basically, you can try the enterprise in browser. You can take a look of the documentation of the open source solution and project. You can see the GitHub repository that we have, and we are also open to receive your contributions. Don't hesitate to make any contribution. We will love to see more from the community. And also you can book a demo for the enterprise. So take a look of this, take a picture, and also you will receive the information. And Adonai is also pasting that in the chat. Thank you, Adam. Okay, question mark here is how could we integrate 51 in our MLOps pipeline if we have multiple steps, multiple tasks. So basically 51 integration is open source and you can create a lot of connections with model evaluation, with performance metrics. You can also run real-time deployment. You can also, for model training, you can use different kind of frameworks to create like a supervised learning, unsupervised learning. So can I, yes, give me 1 second. And also do data annotation for manual annotation, automate annotation. So you can see here all these steps. Even if we are not covering one specific task, you can run the integration and basically centralize all of your MLOps pipeline using 51. So let me come back to the QR codes because someone is asking to do that. So Santos, please take a picture of this, a screenshot, and go for those QR codes that you need. Okay, perfect. So let's talk about evaluating and improving models. So let me just run this. You can access this in the notebook number 5. So basically what we have here, maybe this video is so fast. We have, when you open this, when the embeddings are, when the dashboard is, so with the plus sign, You can go to model evaluation. When you go to model evaluation, if you already have a variable of model evaluation, you can take of the true positives, false positives, average, accuracy, a lot of information. I and no matter what, so you can also interact with those false negatives. You can see what kind of data I have with false negatives, what kind of data I have in my confusion metrics, and see what kind of information I have in the diagonal, what kind of information I have out of the diagonal, and take a look and inspect your models easily. It is easy to see when you are running with hard code that, yes, I have XYZ number of true positives, true negatives, false negatives, and you can calculate everything. But visualize that is always hard, and also centralize. Okay, if you centralize that, maybe you can define that your model is failing for some specific reasons. So there is one question in the chat that I want to answer. It says, Swati say, it is possible to query this data set by using prompts, using VLMs? And the answer is yes. Yes. So, and it's also one of the possibilities, for example, for the clustering part, so that you can use maybe a connection with OpenAI, or the preference, or you have maybe the model locally, and you can use that to create zero-shot classification for those and find those categories instead of adding numbers. So you can also use VLMs and connect the clustering part with zero-shot classification. And yes, you can also use VLMs with FiftyOne. Could we paste in the chat maybe some integration with the latest VLM? So we have integration with multiple. That will be really, really nice to see different kind of, if you prefer one or other, we have a lot of integration with the newest VLMs. Okay, thank you, Adam. Okay, so I also have the notebooks here on my side, but regarding time, I want to be conscious of that. So we have also the integration with curation, with the augmentations. So this is the reason that sometimes with anomaly detection, because sometimes the lighting conditions are changing, but we don't have that in the original data set, we need to create some augmentations. We have the way to interact with augmentations with the library augmentations, where basically you can create the number of transforms that you want to run. You can select here, every single transform you can select from, crop image, change the color, and you can add also the values that you want to add there and create a lot of information, like creating like a simulation of the conditions that you are looking for. So finally, you can run this, and easily you can add those augmentations in your data set. So here, for example, we were turning the color and the contrast and the brightness of the images. Okay. Somebody's asked, the question is, do we get the recording, please? Yes. So please review your email in the coming days, and you will receive this recording as well. And you can also check the Voxel 51 and subscribe to the Voxel 51 channel in YouTube and receive the recording later today. So, but remember, so the chat is not available after we finish the webinar. So if you want to keep this conversation after the webinar, please join our community in Discord. I think that maybe Adonai could share the link that we have the Discord channel. Okay, let's talk about complex data sets. Complex data sets could be something like video analytics, Maybe we want to extract embeddings from videos, or we could talk about 3D point clouds, multimodality, even something simple like an object detection for worker safety. So we will explore the notebook 7 that is related with 3D point clouds. So let me see if I have here the notebook number 7. Oh yes, so I have here the notebook number 7, and what we have here is an MBTech, also has MBTech 3D. There are multiple categories. I'm just extracting this potato, and you have the label. I also already shared this with you, so you can select the abnormal potatoes and take a look of that. So let's take a look of this one, for example. So as you can see here, we can group the the information or the samples. In the sample, we can include multiple information. That means that in the same sample, when I'm opening the sample, I have not just the image, not just the segmentation mask. I also have the 3D point cloud of this potato, and I can navigate this and take a look of this potato and see, maybe where the problem is. So let's take a look of others. So here you can see some problems as well. The point here is that in the message here with this demo is you can navigate complex data sets as 3D point clouds and include that information, and visually you can inspect that visually and understand the complexity of every single information and field that you have for your sample. This is super important. Okay, you have access. So I think that you have access to this the sample as well, because I already create like a subsample in my own Hugging Face hub, so you can explore that from there. Okay, let's move forward. We have also new data sets. I'm so proud to be part of these. So MBTech AD2, so MBTech launched new data sets. I think that was in May. We were co-organizers of the anomaly detection channels in the VAN 3D point workshop at CVPR. And this is, part of the enabling material that I have been prepared for the challenge. So where you can explore the data set, you can explore that you have multiple kind of categories, but also they are creating this amazing data set, because normally when you are running this anomaly detection in manufacturing, the industry, there are a lot of changes that have not been considered in the benchmark data sets. So right now with this data set, we can consider those shifts that we have overexposure, that we have, excuse me, some limitations with the lighting conditions, with the position of the objects as well. So let's see if I can show you that in real time. 1 second. Okay, no. I think that I don't have that here. Hold on. Oh, yes, see, I have here. No, I don't have that. Okay. Oh, okay. I don't want to jump. Okay, this is Ambitech. Yes, this is Ambitech. So where basically, for example, you can explore you can explore data set, you can include these ad plots that I showed you before, and you can visualize what kind of shifts they have. So I already made this, but let's take a look at the categories that we have. Let's make category, and they use the category label. And we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 categories. I will create this and I will say, okay, let me add a new one. And you can explore this data set. And let's take a look at category histogram and see the shift that we have and the shift type. And you can see that we have multiple shifts for overexposure, underexposure, regular, that is normal, and they have also shift 1, 2, 3, 4 with multiple lighting conditions. So that is an amazing, amazing benchmark data set that you should use if you are working with anomaly detection. So let's move forward. There is another Vallejo bath that basically they have also anomaly detection for this kind of elements. They present their research in our Meetup series that was last at the beginning of this month. And this is a great addition also to our repository because they can explore and create a benchmark as well with this data set. Okay, we have also a new data set that is worker safety, where basically you can navigate this one and you can take a look of all the ground truth information regarding what kind of elements the person is that is making a work is needed. So we have maybe gloves, we have maybe vest or safety, or maybe some tools. We can explore that, and also we can run verify auto labeling. So where basically we can test, we can say and prompt the data set to create the auto labeling of these specific objects for the worker safety. Okay, so we have also the video data set that is a really nice integration that we have with 12 Labs. So basically in this case, what we were doing, I want to explain what we were doing in this notebook is that you have access to 12 Labs, that is a video analytics library or platform. So you can load the videos there, extract the embeddings, not just for the video, also for the audio, and send back these embeddings to FiftyOne, where we can visualize those embeddings. So basically the result that I am showing you here is that we made that process. We connect with 12 Labs and we were able to extract the embeddings from the video analytics platform that they have, and I'm able to create those embeddings, and this is working in the same way that basically I can extract and see that we have the lift there, the fork there, so we have the maybe some is unsafe information, so that maybe people is working on unsupervised person there. So basically this data set is regarding safe and unsafe behavior in this factory. This is safe because they have a supervised person there, and we can see that there are some embeddings related with those actions as well. That is really, really important, and I think where is the things are moving for video analytics. Okay. Okay, so wrapping up. So finally, I hope that after this workshop, you think the same that me, that we have a coherent visual AI platform with FiftyOne. So where basically, in my experience, I can say that we can save time, we can reduce cost, and we can improve the accuracy of our models, and we can enhance the answer of our systems and models in production. Because remember, it's not just the model, it's what the model is doing. So we are activating a machine, we are activating an actuator. So what we are doing with that information is not just fill a dashboard. We have some actions that we are taking as well. So Voxel 51, in Voxel 51, we are so proud to be the lead maintainers of this open source platform called FiftyOne. and we are so proud to make visual AI a reality. And for that reason, I invite you to try this by your own. Pip install 51, try the tutorials, navigate the documentation that is amazing, join our community in Discord, and also attend our events. That we are making events every single week. We have one event, so and that's amazing. Thank you so much for your time and your attention. If you have any questions, let me know. Thank you.